Yes. Yeah. Recording should be started now.
Cool. Yeah, I'm happy to take over, Mark. I think that will
All right, then I'll
be
stop
easier.
sharing.
Let me share my screen. Cool. I'll click the button by now. It takes a couple of seconds. Yeah, hi everyone. I'm Josh. As Mark said, I'm a software engineer at Diagrid. And yeah, I've been working on a feature kind of putting under the umbrella of actor state TTL. I was hoping that intro would be long enough for the screen to start sharing, but I don't think it's happened yet, has it? Give me a shout when it's done.
We see it, yeah.
You do see it? Okay, brilliant. Great, yeah. So yeah, like I said, I've been working with the other folks on the Dapr project on this feature called, as I said, this kind of umbrella of actor state TTL. So to give some context, so if you're not familiar with actors, so actors as a computer science kind of paradigm, I guess you would say, is not specific to Dapr, but it's a kind of paradigm that's kind of provided by Dapr. And the idea of actors is that you have these kind of, I've taken a bit from the documentation here, but virtualized virtual isolated unit of computation executed independently. That's quite a mouthful. You can think of this as you have a system with lots of independent processes that need to run independently, and actors is basically a paradigm of a way of how you manage that. So you have what they're called actors. They're running independently, and they're kind of doing some work, and they can they're created at the time of invocation, so you can consider them as kind of ephemeral, and that's where that word kind of virtual comes from. You don't define your actors in any kind of state before you run your program. They're kind of created on the fly. They're intended to scale to thousands, so you can imagine some use cases for actors is you'll want to manage some kind of session. Maybe you want to use them to manage a basket for a website or something like that, and the scale is yeah, it can kind of grow to thousands. They can send and receive messages, so as long as one actor can know the kind of the name or the ID of another actor, they can send messages. And certainly actors can create sub actors, so you can kind of have a hierarchy of actors going up to a parent, and they can send messages to each other. And finally, and most importantly, for this, what I want to talk about today is it can write and retrieve state. So the state that it writes and retrieves is isolated to that particular actor instance, but it's important to know that it can write and retrieve state. Those are worked with the computers at all. The things that should scare you is that this thing can scale thousands of times, and it can write and retrieve state that is persistent. And so that's obviously some red flags. And indeed, in today in Dapr, when you use actors and you're using a state store, think your Postgres, your Redis or something, whatever you're particularly using, it's writing to a database table, and without any kind of mechanism that you implemented yourself, kind of out of band of Dapr, that database is going to grow indefinitely, unless you've implemented some kind of cleanup logic in your program. And that isn't great, right? Yeah, it means you're going to write an infinite amount of data to your table, and the database is going to get slow, or your reads or writes are going to get slow, or you're just going to plain run out of space in your state store. So this is the kind of problem statement where we're at today. So the way we want to solve this is that yeah, we want to have some kind of mechanism for deleting the actor state after a period of time. And it's important that we kind of want the state to be deleted after a period of time, dependent on the context of the program. One could, if they know, all of the programs that are going to be written against a particular Dapr installation to, run a garbage collection routine, and delete all actor state after a period of time. Maybe that's fine, but it's a very kind of coarse brush. And if a developer wants to write a new program against your particular installation of Dapr against the same state store, maybe a minute isn't good enough. Maybe a month is too quick. So we want the developer to be able to manage the kind of time to live for a particular piece of actor state. So the way we have gone about fixing this is, we want to expose some kind of API call. So when you store your actor state, you're also declaring how long you want to store that state for, and kind of keep the kind of developer empowered and making those decisions. So the way we have done this is that the TTL kind of record TTLs, state TTL already exists in Dapr. So it makes sense to piggyback off of that. The only problem is that not all actor enabled state stores, at least pre 1.11, support TTL. So if you think for your kind of databases which natively support TTL, I'm thinking CockroachDB, I believe, does. It's fairly simple for Dapr to as it's writing a particular record to the database to kind of append that TTL information to the actual database, right? Not all actor enabled state stores do. This is particularly true for SQL based databases, your SQLite or Postgres or what have you. So we need to, or we've spent time to implement that. So the way we've done that is that we have extended the database schema for these SQL kind of based databases, and we've included a TTL table. And that behaves kind of how you'd expect. So when I'm using a latest SDK, in this case we're using Go here, we add a time.minute, and as Dapr saves our actor state to the database, it's going to populate that TTL column with the appropriate time, and that's fine. Now we actually have to do something with that TTL information, because of course SQL based, a lot of them databases don't support automatic garbage collection by default. So what we've done is we've had Dapr to be responsible for cleaning up these old records, and the way that we've done that is that we have another table in our SQL or state components that Dapr creates on boot, and we store the last cleanup. So what will happen is periodically, in a kind of default period of time, or this can also be configured, Dapr will check whether the database record has, or the database kind of state table has been garbage collected. And if it hasn't been for a long enough period of time, then it'll go ahead and do that garbage collection and then update the last cleanup time. And this means that all of the Dapr in your installation connected to the same database are kind of self-selecting and having some kind of coordination, so that all of them can optionally go ahead and do the garbage collection. And you get the kind of end result that over a period of time, database records that we don't need anymore, according to the developer, are deleted. We have no more kind of apocalypse disks running out or anything like that. So for end user developers, what this means is that in 1.11, when we update the SDKs for the kind of actor kind of state APIs, we would expect that developers would switch always to using this set with TTL functions rather than just the set. With the attention here that you should always be putting TTLs on your data, So you don't have any of this run out of memory, run out disk space problem. And yeah, so we've implemented that for Go. That pull request is open, but we should expect that all SDKs will support this functionality in 1.11. Great, that's it for me. I'll hand over to Mark, or unless there are any questions that I can.
Yeah, let's check if there are any questions about the actor TTL first. I don't see anything in chat. This one from Philip. How does Dapr track what actors currently exist in order to determine which have passed their TTL?
Yeah, it's a good question. So it doesn't. So the way that Dapr is tracking what to delete, it's specifically just on that TTL column. So whether or not the actor itself exists, it's kind of by the by. It has no relevance.
Okay, thanks. Anyone, any other questions? No? All right. Then let's move over to the next section. Thank you, Jos.
Thanks.
You want to start with sharing your slides, Alice, or shall I do the slides?
Yeah, I can do slides, Mark. Just give me a sec.
All right.
Let me know when you can see.
You can see them.
Cool. All right. This is a big diagrid party today. Very fun. Hi, everyone. My name is Alice Gibbons. I'm a customer success engineer at Diagrid, along with, a few other folks on this call. And I just wanted to start by, if you have never come across Diagrid before, we are a startup that was founded by Mark Fussell and Yaron Schneider about over a year ago now. So we're over a year old. And our mission is to boost developer productivity by providing tools and APIs for building and operating cloud-native applications. And I wanted to give you a quick overview and a quick demo today of what our first product, which is called Diagrid Conductor, is and what it can do. So I'm just going to go to the next slide. And so essentially, as many folks on this call already know, the primary place to run Dapr is in Kubernetes. And we see, over 90% of folks pretty much who are running Kubernetes or running Dapr today are running it on Kubernetes in production. And so what Diagrid Conductor aims to do is it drastically lowers your overhead to run Dapr in production, as well as gives you insights into clusters and your applications, specifically your Dapr applications, for things like additional observability and monitoring, and then provides you with best practices for running Dapr in production all up. And so we see, Kubernetes is the kind of the de facto or the best place to run cloud native applications these days. We also believe that Dapr is the best way to build cloud native applications. And then we think that Conductor is sort of the way to operate, because, Kubernetes is hard. It's not Dapr that's difficult, but in fact, it is Kubernetes that's the difficult part here. So what is it? How does it do? How does it work? Actually, first, the challenges for operating Dapr. Many folks at our company have worked for a very long time helping people run Dapr in production. And so some of the issues that we've come across with customers really is around like the installation, upgrades, and just like Dapr management all up. And also creating visualizations for analyzing metrics, logs, and really alerts for problem solving. So alerts to kind of dig a little bit deeper into what might be going wrong on your cluster. And then, providing, again, best practices, as well as figuring out where misconfigurations lie on your cluster itself. And so, this is on the right here, we kind of have our little Kubernetes cluster running the Dapr control plane, and then, your apps as they might be. And so how Conductor works is it is an agent that you install on your cluster. It's really small. And what this does is gets data from all of your applications and their sidecars around like the metrics, around the version that's running, around all the configuration options that you can configure with the control plane. It sends that to Diagrid Cloud or Cloud, and then it displays it back up into the UI as well. So I'll go into a demo in a second here, but yeah, the three main three main areas that we really focus on is, again, the maintenance of the Dapr installation and advisories for best practices, and then a huge focus on observability and alerting for things that are going wrong, and then as well just improvements on visualization, because if you're running Dapr just without anything else, it's not a very visual thing, and it can be hard to conceptualize generally. So with that, I'm going to hop over to demo. You should be able to still see my screen here. So this is sort of the Dapr Conductor dashboard. This is sort of the first place you would come in. You had an account, and you would see all of the clusters that you have that are running Dapr today. And you have to onboard each of these individually, but it doesn't take very long. So if I want to create a new one, I have a client cluster running on my local machine here. And Conductor supports the three main cloud managed Kubernetes providers, but then also Red Hat OpenShift. So if you have any managed OpenShift distributions as well, it also works for that. Then if you're using a distribution that's just running on your local machine, you can use the other distribution. It runs with like Kind and Docker Desktop and things like that. And then I want to choose if I want to install Dapr. So this is kind of where all the configuration comes in. So if I want to have a fresh install on, brand new cluster, has never really run Dapr before, I can do this. Or if you have Dapr already running on your cluster, this will actually just do an upgrade. We support all the main versions of Dapr that are supported upstream. So I believe there's an N-2 SKU support version policy. So where 1.10.4 is the latest, and obviously it goes down to 1.8. So I'm going to choose the most recent version here. And then I'm going to keep this option enabled on the left-hand side. And this is actually going to allow Conductor to be the single source of truth for where all of my Dapr configuration lives. So essentially, if someone else comes in and changes something by accident, or fat fingers the configuration, this will actually overwrite that within the cluster. So again, making Conductor sort of your single pane of glass, as well as single source of truth, whatever words you want to use there. Then I'm going to come in here and decide which profile I want to use. So we have these recommended Helm arguments on the right here for essentially the Helm arguments for each of your profiles. So for dev, it's going to be a little more lenient, and then for production, we have things like MTLS is enabled and high availability is enabled, as well as a bit of a longer watch interval for the Dapr watchdog. And then you'll also notice that all of these requests and limits are set for you for the Dapr control plane resources, which, if you're aware, in upstream, if you're just running the Helm charts, you have to set all these yourself. So these are set with sort of values to start with. You can obviously change these over time. And then I'm going to enable this automatically rotate certificates. So if you're familiar with Dapr certificates, you'll know that the upstream project provides MTLS certificates that expire every 12 months, and those are assigned with self-signed certificates. So what we do in Conductor is we actually provide our own certificates, and then we rotate them for you with no downtime at the frequency that you'd like. So for instance, if you're like, I really want to rotate them on the 1 month frequency, and I want to do it, try to do it on Sundays. I think this is 7 in the morning or something. Then you can do that, or you can choose the frequency that you like. Again, this should cause no downtime for certificate rotation, which is like a huge issue that we've come across with customers running Dapr in production. There's a few other configuration options here, but essentially all I'm going to do is hit create, and then I'm going to get this kubectl command that is going to apply these manifests on my cluster. So I'm going to copy that, and then I'm going to flip over to my terminal here, and I'm actually just running. So yeah, I have a Kind demo that's running here. You can see I don't have Dapr or anything installed on it now. Again, this is just on my local machine, but really could be anywhere so long as that I have egress access to our APIs. And then you can install that. I'm going to copy and paste that command. You see a bunch of things getting installed on here. If I want to inspect all the manifests, that's something that you can do. But essentially what is created is a daemon set and deployment within the Dapr agent namespace. So if you see Dapr cloud namespace, Dapr cloud namespace is where we deploy the agent and a version of our OTel collector for logs and metrics collection. So that was created, and then you'll see actually now that this Dapr system namespace was created as well just 4 seconds ago. So if I click done, I should see now I have a new cluster showing up in my dashboard, and then Dapr not installed yet, but once it gets installed, I should see a status for the control plane as well. So yeah, if I come into a cluster that already has it installed here, you're going to see a ton of values from the control plane right away. So I can see things like when the root certificate expires, if MTLS or high availability is enabled on my control plane. I can jump into the status of the control plane right here. Again, I'm running in HA mode, and you can see that each of the pieces of the control plane is shown here as its own pod. I can see their memory and CPU usages over time. Heading back to the sort of the main thing here, I can also get an idea of how long my control plane has been up for. I can see the CPU usage of the control plane and the memory usage over time. So we get a bunch of really pretty graphs that I can view, if something's taking more memory than it should, things like that. And then if I come into advisor, this is sort of where the best practice recommendations come into play. So we have 4 main categories that we recommend these best practice advisories in: security, performance, reliability, and observability. And they're all rated by high, medium, and low impact levels or severities. And these are they range from a lot of different things. I think we actually have over 35 recommendations that we recommend to people, but they can be up to 35. I have 17 on this cluster, but it obviously varies depending on your installation. So for instance, a very common example of like a security recommendation that you get is like if you're not using a secret key ref within one of your Dapr manifest files. So, I'm sure lots of people in this call are familiar with this, but instead of displaying your secrets directly within your manifest files, you should always use a secret key reference and reference a state store of your choice, whether that's key vault, whether that's vault, whatever you use. And then this is actually telling me what resource or what manifest this is actually happening in. So for instance, if I click on that resource, I get navigated over to this components tab, and you can see if I open my OMS pub sub, which is a Kafka broker that's actually just running on my cluster, I can see that this password is actually stored in plain text here, which is bad, right? You don't want this to be checked in along with your code into GitHub or whatever. We do obfuscate the passwords just for the UI here, but that would be a plain text password that's actually in your cluster. Heading back to advisories, there's a ton of other things here. So for instance, if you are not providing scopes on your components, that means other.
Okay. WhatsApp करो.
ठीक है. SBIO करियो है.
I'm just getting some noise. Many other applications within your cluster can access the infrastructure components. So that's not great. One other thing I want to highlight is the performance recommendation. So, we talk a lot about recommending best practice resource and requests and limits for both the sidecars as well as your app containers, right? So for instance, I can see here, what applications are not actually having the sidecar requests and limits specified within the annotations. It's going to give me recommendations for that. But then if I come into one of these apps, so this is app specific now. So this is saying application here. What it's actually going to do is it's going to say, over the past 10 to 15 days, so it starts at 10 days and it goes up to 15 days usage, the Dapr sidecar observed memory and CPU usage of 3 millicores and like 19 megabytes approximately. And then based on these values, it's going to recommend you new sidecar requests and limits for this. And then similarly for the application container as well. So in this case, my app called Makeline Service has used 1 millicore and 33 megabytes, but then it's telling me new request and memory limits based on that. So again, all very specific, and we've actually found that customers have been able to save some money by applying these directly to their clusters or directly to their apps rather. But if any of these aren't really something that you want to apply, you can always dismiss them. And dismissing advisories will just remove them from your list right here, and you'll see them under dismissed on the side because not every advisory. This might be a dev cluster, or you might not want to enable your JSON formatted logs, for instance. Maybe you're not using maybe not using a monitoring tool for log search or something. But then some of these actually are auto fixable as well. So I can hit this fix advisory, and what this is going to do is it's going to actually apply, in this case, the global logis JSON value to the control plane, and then automatically give my control plane an update, which is cool. So that's kind of advisor. I can also head into my applications view, and this is going to give me like a more holistic view of all the apps running on my cluster. So for instance, I have 8 Dapr applications running on here. This is a order management system that I have deployed, and I can see, the namespace that they're deployed in. I can see the health status. This health status is a combination of both the application and the Dapr sidecar. So it's going to look at both of those and then surface that up here, as well as like Dapr app ID, which we know is a super important construct within the Dapr ecosystem. I can also look at this within the apps graph view. So if you're more of a visual person and you're like, hey, I would love to figure out like how my applications work together. I can look at this and I can see, hey, this is how my apps are connecting. And so you can see there's a number of different lines. You can see there's a number of different lines showing up on this graph. There's a little legend on the bottom here, but essentially the straight lines, or the solid lines rather, those are the service to service invocation. So it's using Dapr service invocation API. And then these dotted lines, these are using PubSub. So you can see on the left, I have a number of publishers, or I have one publisher, sorry, and then that's publishing to a number of subscribers on the right-hand side. I can also get a more of a specific view by isolating on an app. And I can also see, if something's not right. So this one looks like it's not running at this moment. So that might be something I want to look into. But if I isolate, so this time I isolated on order service, which again is my publishing app. And based on that, you can see there's a number of metrics that are showing up on each of these edges. So it's saying, on order service here, zoom in a bit, it's publishing with an error rate of 0%, RPS, and latency. So kind of the golden metrics on each of these edges. And this is actually just using Dapr metrics. This is not using, like, you don't have to have tracing set up for this, which is a question we commonly get. And then I can also isolate on the components, or the components themselves, so the infrastructure. So in this case, the PubSub is a Kafka component, as I mentioned. I'm going to get some of the details on the right here. And then I can see a ton of the metrics coming from everywhere. So it's a bit of this case is a bit of a messy graph, but if I wanted to see, like for instance, it looks like I have an error rate of 100% coming from receipt generation service going out to this output binding. This might be something I want to take a deeper look into. So I can isolate on this service and then zooming in, again, I might want to look at this a bit further. So diving into the app specific view, I can click this link. It's going to navigate me to my app specific view on my cluster. So again, this service is called receipt generation service. The job of this service is primarily to store audit information for each order that comes through. And I'm going to get a ton of information here. How many replicas, so how many active components means like how many components have been called out to or been used the past 5 minutes. I can see app and Dapr container restarts. I can check out those annotations, the Kubernetes annotations that are deployed with this application. And then I can see the CPU and memory requests and limits for this app. So it's saying, hey, these resources are only using like 0.38% of my requests, or only 1% of my requested CPU in this case. So this might be, again, other ways that you can decommission some of your like nodes in your cluster or something to save money. And then similarly, I also have CPU and memory usage broken up by app and Dapr sidecar. And again, I can view these over time, just like the other graphs that I showed. So a few spikes and dips there. And then coming into throughputs. Throughputs is where I'd say the graph gets really interesting. This is going to show me a breakdown of both HTTP and gRPC calls from your application to the Dapr sidecar, and then vice versa. So for instance, this application is written in .NET and uses the Dapr SDK. So a lot of all of the API calls rather are using gRPC, but I can see, there are a few calls in here for HTTP just for like the health check and the config that like Kubernetes does. Similarly, I'm invoking a binding. This is my one through gRPC. So I can see latency, requests per second, and then error rate for both gRPC and HTTP requests. So these are all broken down. So coming down to the very bottom here, I'm getting an error rate. You'll notice 100% error rate on this orders call within this app. And then this also is giving me an error rate of 100% onto my invoke binding call. So again, this is an app Dapr sidecar call. And I can see, let's see if I add this, I can see it's been going on for a while. So this might be something I want to take a deeper look into. So I can go to two places now. I can go to the components tab, and this is going to show me the components themselves, like what components are specifically loaded for this app. I can see if they're active or not, meaning they've been used in the past 5 minutes. We have this initialization status field. So what this is doing is, if you're familiar with the initialization methods for each open source component upstream, it's actually calling out these init methods and ensuring that we can establish a connection to this component. Just again, to give users more insight into like debugging their apps. I can view the raw manifest file, copy it, nothing too exciting there. But then I can also see the metrics for the component itself. So for instance, the component latency, kind of like how that's changing over time. I can also see RPS for any components that are being called from this application, and then error rate. So you can also see this is, this is also giving me 100% error rate for these apps. So that's maybe where I'd come first. But then if I navigate over to notifications, this is where I'm going to get kind of the debugging information for my application. So for instance, so by default, we collect all of the Dapr sidecar logs of warning, error, and fatal log levels for all of your Dapr sidecars. You can just filter on logs here, and this will show like all the warning, error, fatal logs. You can see I'm getting one very consistently on reaching out to or processing one of my Kafka messages. But I can also filter on metrics. And so metrics are rules that we have set up for you by default. And this is going to trigger an alert essentially when any of these metrics have a non-zero error rate. So for instance, you could see in here, I'm getting a ton of stuff. But like one of these ones is saying, hey, my app, Dapr to app HTTP error rate has been more than 30% for 2 minutes. Again, just giving me more insight into what might be happening with this error. And I can also see it's happening on my receipt and my pub sub binding. This is a Redis binding, and this is the Kafka broker. And then as well as I'm getting a high gRPC error rate as well. So these notifications are set up. So if I jump over to the notifications tab, this is going to be my notifications for like all of my applications in my cluster. But going to rules, I have a huge amount of these rules already set up for me. So essentially, like anytime my Dapr sidecar is crashing, anytime, as I mentioned, my Dapr to app HTTP or gRPC error rate is above 30%. And then, if I am getting any error rates within the metrics for components as well. And I can actually send these. So right now I'm just sending them to Conductor, which is like the UI here. But what I can do is I can add additional channels as well to go to a webhook or go to email. So if you use or if your customers use like an integration, have an integration with like PagerDuty or Azure DevOps, Azure Monitor Alerts. We have like people using the Logic apps as well for these integrations. You can send these alerts anywhere to get insight into your applications. But yeah, many options there. I can also, coming back into my cluster itself, I can see, I can also do, so one of the other things that we offer actually is like Dapr upgrades. So as I mentioned before, you can install Dapr freshly on a cluster, but if you already have Dapr running, then you might want to upgrade to the newest version. We try and get versions in here super, super quickly. As soon as pretty much they're available upstream, it'll be like a couple hours, and then they'll be in Conductor. We also put release candidates in here. So we have many customers that try out release candidate versions before they actually get pushed upstream, or before they push the fully released version. And so we try and get the RCs in here as well. So again, what I can do from a release upgrade perspective is upgrade the version to 10.4, the newest version. I can also decide if I want to roll out all of these applications. So I'm sure, as most of you are aware, rolling out all applications is something that you typically have to do after a control plane upgrade within Dapr. And you have to do this because you'll upgrade the Dapr control plane to the new version, but then all of the sidecars themselves need to be reloaded in order to get that version. So I can decide to roll out all apps after the control plane upgrade is successful, or I can choose, a subset of these apps that I want to get that new version, for instance. I can also, so these Helm arguments are being pulled from my cluster right now, so I can see what, is currently deployed. But maybe, maybe I want to change some of these guys. Maybe you want to, disable, which this was something I just enabled via an advisory. Maybe you want to update my watch interval of my Dapr watchdog. I can do whatever I want here, right? This is just Helm arguments. Anything that's supported upstream can be there. And then I can also schedule this update. So maybe I want to schedule at a time when I'm receiving less traffic on my cluster. These upgrades should not cause any downtime. Again, we do like a kubectl rollout restart on all the apps that we're upgrading after that upgrade is successful. But if you, again, still want to do an upgrade at a time when no one's using it, that's probably best practice. The version, so when we upgrade a version here, you'll see it upgrading within the Dapr version area, and then you'll also see this Dapr status go to degraded. And what we're actually doing in the back end is once this is, so if this upgrade fails, we'll actually do an automatic rollback for you. So this is a feature that many customers really like. Reason being is, if this upgrade to 1.10.4 fails, it's going to roll me back automatically to the previous version of Dapr. So that was successful, so which in this case was 1.10.3. And then while this is happening, I can come into the control plane health and just monitor this. So for instance, you can see, one by one, I'm going to get some new pods running within each of the services. And then slowly but surely, this should all be upgraded to 1.10.4. I can also view this in my agent logs. So heading over to agent logs on the right here, this is going to give me a just a better picture of like what the conductor agent is really doing, right? So for instance, it's going to tell me, hey, upgrading from 1.10.3 to 1.10.4, this was successfully applied. So then it's going to roll out those 3 resources that I chose, right? So then if I head back to here and go to applications, actually it might not be, okay, it's almost done. So you'll see now, if I look at the Dapr version of each of my apps, I only have 3 of them, the ones that I chose that are running 1.10.4, and then the older ones are still on 1.10.3. Additionally, I can also roll out all my applications using the UI as well. That's just, a feature. If you don't want to roll out any and you want to check the control plane working, and then you want to roll out all of your applications after, something you can totally do. The other feature that I guess I didn't mention was like the reverting. So for instance, if you want to revert to a previous version or even just previous Helm values that you had deployed in your last upgrade, you can go press revert, and then you can see, your Dapr version is now, or used to be 1.10.3. These were the resources that I decided to roll out in that previous upgrade. And then I can see a diff here of the Helm arguments. So for instance, remember I changed my watch interval from 2 to 3 on the watchdog. And then I think, yeah, here you go. I also I changed that log JSON value to be false, for instance. I can see what values were changed. And then if I want to perform a revert, which I won't do right now. Yeah, that's mostly what I wanted to show. I think there's lots of other features that are all built into each of these tabs. So for instance, we have I think I mentioned the component initialization call. So if you have errors that are showing up on component init, I can see them in here in the manifest YAML. So for instance, this is telling me I have a error occurring for this specific component for connecting to Redis. It's saying it's not able to look this up, so giving a time. So again, just showing me that this is actually going to be something that I might want to look into before deploying any of the apps that this is scoped to. Similarly, yeah, resiliency policies, they also show you if they're being used or not. Okay, yeah, this one's not being used right now, but coming into an application specific view, I can also see anytime a resiliency policy is being called. So that's really handy for people, and you can also see the graphs for when they're being used. So over time, if it is being used consistently or not consistently enough, that's something that you might want to look into. And right now we show that at the application level. that was mostly what I wanted to show. I guess there's a few questions in the chat.
There is one from veterans. So indeed, people have questions. Either put them in the comments right now or ask them when we're done. Some more are popping up. I'll read them out loud for you. So veteran is asking, can we compare Rancher with Dapr Conductor? Is it a similar tool, similar purpose?
Yeah, interesting. Yeah, I've seen people use Rancher for like multi-cluster management at scale, right? So it would be like if you had a huge cluster fleet, and then you wanted to apply like similar configuration across all of your infrastructure, which again, you can do that from a Dapr perspective within Conductor, but Rancher has like more Kubernetes specific features around RBAC. So for instance, there actually is an RBAC model, which I didn't talk about in Conductor, but it's not Kubernetes RBAC. So for like most customers that I've worked with that are really big fans of Rancher, like love it for the RBAC integration and the command line integration and the shell that it gives you into Kubernetes without ever having to go into like kubectl essentially. And that is similar to Conductor from a Dapr perspective, but again, if not necessarily not entirely related, just because I think of Rancher for more like infrastructure configuration, right? And we want this to lower your operational burden or operational overhead, but won't give you the options for configuration of Kubernetes that Rancher will. Good question. So, but I guess the only thing I didn't mention while we were talking about infrastructure is that all of this I showed today is actually available to be managed via an operator. So if you use like a GitOps or Flux, or if you use, whatever your favorite GitOps tool, what you can do is you can install the Conductor operator on your cluster and then configure we have a cluster CRD or cluster connection CRD. And this is going to be all the configuration I showed you today. So you can configure the, certificate rotation, you can configure, your upgrade, your version, all your Helm values, things like that. And that just allows you to provide all of this declaratively instead of like, going through the UI and like clicking. And similarly, we also have a CLI. So there's a Dapr CLI, which we have multiple people that use it in like DevOps pipelines, for instance. Cool.
Excellent.
Okay.
Yeah. There was one other question from Peter. Does the resiliency policy view show the current status of a circuit breaker policy?
No, it doesn't. So this is actually a feature that I actually raised in upstream Dapr. So right now, the metrics themselves, so it's actually the rate. So right now, what we show in Conductor is the resiliency policy rate of metrics. And this is, so all these metrics that are in Conductor are scraped from each Dapr sidecar's Prometheus API, right? So each Dapr sidecar exposes a Prometheus API. We're getting all the metrics from that. But the resiliency policy rate is just the rate at which it's being used. So if it's like 1 the whole way, then it's like consistently being used at 1. But if it's going up, you're using it more and more versus going down, kind of thing. But yeah, that's an open feature upstream that we actually want to get into Dapr open source, is being able to show more granular resiliency metrics. Yeah.
Excellent.
Yeah, and then.
All right. Any other questions for Alice?
I guess the only thing that I would say here is like we're under like constant development of Conductor. We have like many customers that are using it for managing their production clusters, as well as like folks that are doing Dapr POCs. So if you or anyone else want to just do the trial, I'll post something in the chat just around like getting in touch with us. But essentially, let's see if I can find it right now. But you can fill out this form and get a trial if anyone's using Dapr in production or is getting there with the POC. We love hearing feedback, and we're honestly trying to make this product better. So very curious on usage.
Excellent. Thanks a lot for this demo. Perfect.
Yeah.
All right. So thank you both, Alice and Josh, for these two sessions. Is there anything else that someone would like to say, or anything relevant for this community call that they want to shout out? Now would be a good time. All right, I don't think so. So thanks again for attending, everyone. Thanks again for these lovely sessions, and I hope to see you during the next community call. Enjoy your day.
Thanks,
See you all.
Thanks,
Thanks, everyone.
Thank you.